So now we're going to do Prim's algorithm with a table. The algorithm doesn't change, the steps don't change, but the process might be a little bit different, and your school or academy might be teaching it. So I'm trying to show you how to do it. And we're going to use the same exercise, one of the same exercises that we used before, so that you see that we get the same result. Okay, so the first thing we're going to do is create the table. How do we create a table? Well, we're going to put in rows and columns all the vertices that we have. So it's A, B, C, D, E, F, G, and we have here A, B, C, D, E, F, G. And now we're going to create a table with those vertices. So I'm going to use the tool I have here that I can with a straight line. And so very quickly I'll create a table. And you'll see that in this table we're going to do the same process of the algorithm, and we'll get the same result. But it's some academies like it because it's a very systematic way to do it. Okay. First thing to do, we're going to dash out the cells that are the same letter, so AA, because we don't want to go from vertex A to vertex A. Okay, so we're going to, and they're all in the diagonal, so all these go out. Sorry. Okay. So all those go out, we don't need them. And then I'm going to add all the weights of the edges. So A and B has a weight of 2, and I write it down twice. I write it down in A and B and the cell in BA2. Okay, so each weight is added twice. So A we have also with D, and it's a 5, and DA is a 5, and AF is another 5, and FA is another 5. Let's go to B. It's the one with the most weights. So we've got the one with A. With D, it's a 1. And DB is a 1. With E, it's a 3. And EB is a 3. With C is a 7. BC is a 7. And CB is a 7. BG is a 4. And GB is thus a 4. And BF is a 3, and FB is a 3. And then we have in C, we have CE is a 10. So EC is a 10. And CB, we already have it. CG is a 6. And GC is a 6. And in B we have the E, which is a 2, and ED, which is a 2, and then we have that one's 3, F, FG is a 1, and GF is a 1. So we have all these are covered, and then the other ones have 3 each. So 3, 3, 3, 3, 3, 3. That's it. Okay, so that's our table. All cells might be with a weight or not, depending if everything is connected. C is not connected with A, so it doesn't have anything there. So we can dash it out if we want or leave it blank. Doesn't matter. Okay, so let's start the process. We can start, as in always in Prim's algorithm, with any vertex. I'll choose A as always. So whenever I choose one, I've chosen A. So I'm going to dash out the whole column. Why? Because we don't want to use A again. So now we're using the row A, and I have to select in row A the edge with the least weight. So that's 2. And I'm going, once I've selected it, I'm going to again dash out the whole column. I don't want to use B again. By doing this, I'm canceling any connection of the other nodes with B because I don't want to use it again. I don't repeat nodes in, I don't repeat vertices in Prim's algorithm. Okay. So now that I've chosen B, I can use both rows A and B and select which of all these is the one with the least weight. Obviously it's this one. So again, I dash out the whole column, and I can now use D. And in rows A, B, and D, the one with the least weight is this one. So I'll just dash out that. And now I can use also row E. The least one now is 3 here, so I'll use this one. Remember, we use the least one of all the rows that we've selected. Now it's F, and now I've got the one here, so obviously I'm going to use that one and select the G. And of all the rows I have here, I've got 10, 6. I'm obviously going to use this one. And now I've finished because I've cancelled out everything. So if you can see, I can build my minimum spanning tree by doing from A, I've selected the B with the weight 2. In B, I selected the connection with D, which had weight 1. From D, I selected the E, which had weight 2. From E, I don't have anything. From B, I also have F with weight 3. And from F, I have G with weight 1. And from G, I have C with weight 6. And you can check that this is the minimum spanning tree I got before with the other version of Prim's algorithm, and also with Kruskal's algorithm. Okay. So it's really fairly easy. Select a vertex, dash out the column belonging to that vertex, select which is the edge with the least weight. Then you add that row's edge so to the ones that you can select, and look at all the edges that we have. Select again the lowest one, cancel the whole column, and go on until the whole table is crossed out. Okay.